We're going live now. Mm, okay, that is how I end it. Okay. Okay. Hang on. Okay, thank you. Yeah, good evening. Today, class, we are looking at the subject principles of accounts. And the topic we are looking at today is principles and practice of double entry. Principles and practice of double entry. It is good at this juncture to look at the importance of the topic, principles and practice of double entry. That is, at the end of this topic, the student should be able to define the principle. Number 3, the student should be able to apply these rules of double entry in solving accounting problems, in solving practical accounting problems. Number 4, should be able to identify the accounting concept. The student should be able to identify the accounting concepts. Number 5, not just identifying it, you should be able to explain the accounting concept. Number 6, should be able to solve or answer practical higher mark or have an excellent grade in his or her examination, etc. Double entry bookkeeping. The principle of double entry states that for every debit entry or posting, there must be a corresponding credit entry. In other words, if you have a transaction involving 2 persons, for instance, Mr. Taiwo and Mrs. Jane, if Taiwo is the seller of the goods and Jane is the buyer of the good, if Jane parts with her money to buy goods from Mr. Taiwo, will be credited and the other debited. You debit the receiver and credit the giver. You debit the receiver and credit the giver. should be noted that double entry principle is the basic for accounting. In other words, double entry principle. What that means is so many students failed this subject in their various exams because they don't have the knowledge of double entry principle. The subject again is principles of accounts. We are looking at the topic principles and practice of double entry. The principle and practice of double entry, you may not be able to solve accounting problems. Transactions are recorded or posted to the ledger in line with double entry principle. Transactions are recorded and posted to ledgers in line with the principle and practice of double entry. It requires that for every transaction, one party is debited, that is the receiver, and the other party is credited, that is the giver. Why sometimes it is said that for every debit entry, there is a corresponding credit entry. What we are saying is this: you debit receiver and credit. Examples as we go ahead in this topic. But before then, let's look at in account is the preparation of accounts. Preparation of accounts. Books of accounts. You must ensure that your books of accounts are prepared as one of the procedures. and the very first procedure in the practice of double entry. Number 2 procedure is the division of the account, that's the books, into their separate accounts. Of course, we've been told that every transaction involves majorly 2 parties. So their separate accounts are required. Each account divided into 2 halves. Each account is divided, that is, the giver, who is credited, and the receiver, who should be debited. And the procedure is such that the account should have the debit side on the left-hand side. And the credit side should be on the right-hand side. It follows, therefore, that if you put your debit side on the right-hand, so you would have messed up the account if you place the debit side on your right-hand side and the credit side on your left-hand side. The receiver received is credited with the total amount received, and the giver, sorry, let's take that again. The receiver is, and the giver is credited with the corresponding, let's mark that, corresponding total amount In this circumstance, corresponding total amount paid. Now let's look at.
Can I force you listening so that I can start writing something?
Cash and credit transactions. A transaction is said to be in cash or on cash basis if it is paid for in cash immediately. A transaction is said to be in cash if it is paid for in cash immediately. Or the customer, because it's a one-way thing. But for credit transactions, the payment may not be made until so the agreed period may be 1 month, 2 months, 3 months, as the case may be, based on the agreement. It means there will be need to open separate individual ledgers for them. You should note these steps in recording cash transactions. Preparation of 2 accounts. Preparation of 2 accounts. Then number 2, identification of the giving account and the receiving account. The giving account is to be credited, while the receiving account is to be debited. Then number 2, for every debit entry, there must be a corresponding credit entry. So you cannot debit both the receiver and the giver at the same time. Instead, you debit the receiver and credit the giver. We should note that there are always credit transactions. Reasons being that big businesses, major businesses within Nigeria and around the world allow credit transactions so as to increase their volume of sales. Because history has it that if your transactions are based mainly on cash or in cash, your volume of transactions may be limited. It is therefore pertinent for us to note the steps to take. You must prepare the days book. Preparation of the days book. Preparation of days book. Such days books include sales daybook. It includes returns daybook. It includes the journal proper. Number two, two accounts are required to be prepared. Preparation of two accounts.
Is this mine or yours?
You should identify the given account and the receiving account.
So I should introduce the cost.
Finally, number four, you have to apply the principle of double entry. Without this basic knowledge, it will be difficult for you attempt to do a graphical representation of transactions of both cash and credit transaction. Here you have the transaction, divided into two. One is cash transaction, the other is credit transaction. In cash transactions, please note the preparation of cash book is essential. You have your cash book. On your cash book, you have your ledgers accounts. Very important. Under your credit transactions, you have the days book. You have the days book. Remember, the days book includes your sales day book, your returns day book, your journal proper. It also includes your purchases day book. Having prepared your days book, your ledger account is equally relevant. Ledgers. Your ledgers accounts are equally relevant. memory flashes. In solving accounting problems, apply the principles and practice of double entry. Let's note this. That represents the following. And credit entry represents the following. Under the principles and practice of double entry, debit entry signifies an increase in the value of assets. Increase in the value of assets. You must memorize that. That is, under the principle, represents a decrease in the value of assets. So they always go why the credit entry decreases the value of an asset. Debit entry represents a decrease in the value of liabilities. Under the principles and practice of double entry, debit entry represents decrease in the value of liabilities. That is what the business owes to the outside world. While a credit entry, the amount or value of liabilities. Under the principles and practice of double entry is that a debit entry represents an item of expenditure or expense. Conversely, a credit entry represents an item of income. An item of income. Or may be seen as gain. Gain. Whatever you gain or profit from a business is represented as credit entry. I take it again. Memory verse. What you must memorize. Why credit entry represents a decrease in the value of assets. Number two, decrease in the value of liabilities. A debit entry represents decrease in the value of liabilities, while a credit entry represents an increase in the value is an item of expenditure or expense. While credit entry, having taken that, we'll be looking at some practical illustrations on how to apply the principles of double entry in solving accounting problems. Illustration.
It did not happen again. I want to go to this thing.
Illustration of
Your this thing so that I can
the principles
WhatsApp so I can pick question and start.
illustration of the principles of double entry. Mr. Taiwo started a business with 50,000 naira cash on 1st January
2014, number 26.
2010. This is a question. Mr. Taiwo started a business with 50,000 naira cash on 1st January 2010, and you are expected or required to apply the principles and practice of double entry to this question. In solving this problem, solution, you should note these effects. Note these effects. That there is an increase in capital. There is an increase in capital. Why? Any money one used to start a business is called capital. In other words, capital is the money on the 1st of January 2010. So the effect is that there is an increase in capital. Number two, there is an increase also in cash, in assets.
This thing you said is good. They are repeating questions. Yes.
Please note that cash is an asset. Note that cash is an asset, but a current asset. Current asset in the sense that it is easily convertible to other form of asset. It is easily convertible to other business, and also an increase in the asset for Mr. Taiwo's business. You credit the giver account and debit the receiver account. The giver account is capital. Capital. So you open a capital account. Capital account. Don't forget, your account is divided into two. To your left, you have the debit side, represented by the arrow, and to your right hand side, you have the credit side, represented by your CR. In preparing accounts like this, value, as in this example, is in naira. If it's in dollar, you also indicate dollar sign. If it's in pounds, you do the same. If it's in euro, you do the same. So don't use naira in place of dollars, nor dollars in place of pounds, and so on. Otherwise, you will be penalized by the examiner. Now, capital is the giver, and cash is the receiver. So we credit capital accounts and debit cash accounts. Before we do our posting, I would like us to also open the cash accounts so that we do the posting one time. Cash accounts. Don't forget to divide the account into two equal parts. The left-hand side is the debit, represented by DRO. The right-hand side is the credit side, represented by CR. Now, we post. Look at the question again. Mr. Taiwo started a business with 50,000 naira cash, that is capital, on 1st January. The date is 1st January 2010. And we are opening the capital account. And the capital account is the receiver that has increased. Is to be credited. So on the credit side of the capital account, you write your date, credit capital account with cash. So you write cash. The principle and practice of double entry says that you cannot enter and the asset, the cash that should be debited with the asset. Now you come to cash account on your debit side, you begin with the date 1st January 2010. This time around, we are debiting the asset, that is cash, with the same value of 50 naira, no more, no less. You must get your 100%, the amount must be the same, no more, no less. So, with this, we have successfully answered this question. I want us to note here that the money used to start business is called capital. And another name for capital in business is called owner's equity. Owner's equity. Let me write it here. Owner, then apostrophe S, equity. That is the contribution of the owner of the business into the business. His personal contribution into the business is called the owner's equity or capital. We'll take another illustration. Another illustration. That's this illustration 2. Illustration 2. We are referring to the man in illustration 1. That's Mr. Taiwo. Mr. Taiwo, for how much? 550,000 naira. Cash. On this time around 2nd January 2010. It's like Mr. Taiwo likes cash transactions. So his transactions are always in cash. Applying the principles and practice of double entry, here, from what we have learned so far, the solution will bring about this effect. The effect of this is that having paid rent in cash, it means the expenditure or expenses, the expenditure or the expenses of Mr. Taiwo has increased. has increased. His expenditure has increased, while his cash has decreased because he parted with cash. So the action required will be to open two separate accounts as ledger accounts, one for rent, then two for assets, that is for cash. For rent and for cash. So, like we did in example illustration 1, you open rent account, and divide it into two equal parts, debit and credit. And you have your naira sign. Then you open another account. The corresponding account is cash account. Cash account. In this subject, you may notice I will no longer be using debit credit on the account, because then it will be believed that you have mastered. It's your left hand side, that is the receiver side, the receiver's account side, while the right hand side is the credit side, the giver side. So in this illustration 2, rent was paid by Mr. Taro in cash. Two main things are necessary there. Rent, number 1, cash, number 2. Rent received the money, 550,000. That rent is an expenditure, it's an expense. And while we are looking at the memory verse, we say debit entry represents an expenditure or an expense. And that is what you are saying here. So rent will be debited. The first thing to note is the date. The date is 2nd January 2010. 2nd January 2010. The sum of 550 naira. $550. Now, before we go further, notice the difference between how this amount was written in the illustration and how this amount was written in the solution account, ledger account. You see, you notice that the naira, it means the same thing. But one thing you should note is that in preparing accounts, don't write your amount having the sign, the amount sign, whether naira, dollar, by the side of the amount. Always put it on top in preparing accounts. Whether you are preparing ledger accounts, you are preparing cash book, you are preparing income and expenditure accounts, whatever account you are preparing, make sure your naira sign is on top of the amount, the figure. One of the major reasons being that you have various amounts, either in naira, in dollars, in pounds, in the same account. So you cannot begin to write like this: 100 naira, 200 naira, 300 naira, 800 naira, and like that. Then you want to total, you're not acceptable in accounting. Instead, you write this amount like this: your 800 naira. What it means is that any figure you write under here means is in naira, is in this sign. So when you total, if you have something like this, 1,400 naira, you don't need to start repeating the sign on every amount. No, this is the acceptable way of writing amounts in accounting. Take note of that. So having debited rent with cash, we will not credit cash account with rent. Why? Cash is the giver. Put your naira sign, use your date, 2nd January 2010. We are crediting cash account with rent. 550,000 naira. Is that understood? Rent account debited in the left-hand side because he is the receiver. Cash account is credited on the right-hand side. Cash was given. Cash is the giver. To take another illustration to buttress our points and widen our scope of knowledge in this topic: principles and practice of double entry. And this will be our last example, example 3. We're looking at it in the other way around. Rent 5,000 naira was paid by Mr. Smith to his landlord on 1st July 1987 by check. Rent 5,000 naira was paid by Mr. Smith. Was paid by Mr. Smith to his landlord. To his landlord. To his landlord on 1st July 1987. What that means, Mr. Smith wants his landlord to go to the bank and have value for his money, to go and withdraw the money by himself in the bank. So bank is involved in this transaction. In this illustration 3, bank is involved by the reason of the word check. Check. Okay, we'll go into the solution immediately. Rent is an expenditure item, so the expenditure will increase in the rent account. Then the increase in expenditure decrease in bank. Bank is also an asset, is a current asset, in the sense that it can easily be converted, becomes cash, liquid raw cash. So it's an asset, current asset. So now, 2 accounts are used, then bank accounts, because of the use of check. We don't have anything like check accounts, so don't make that mistake of opening check accounts. Wherever you see check, you open bank account. So we have rent account on the one hand, divided into 2 equal parts, debit and credit side. Then you have your bank accounts. Also divided into 2 equal parts on the debit and credit side of both accounts. And you begin by looking at the date of the transaction, 1st July 19x7. Rent received. Rent is the receiver. So we are going to debit rent. You take the date, 1st July 19x7. We are debiting rent account because it's the receiver with what? With check. But in this case, bank, because we cannot open check account but bank accounts. So we debit rent with 5,000 naira as the receiver. Then you come to the bank accounts as the giver. You write your date, 1st July 19x7. You credit bank account with rent. The same amount, the same value, no more, no less, 5,000 naira. With this, your account is said to have balanced. I want you to note, very important, that you show your date as we have done in our solution. Your dates are very relevant. In fact, if you omit your date in preparing your accounts, the examiner will score you down. If you don't end up losing the total mark for that question. Dates involved, or the items that are involved, in this case, rent and check, which is bank, are also captured. The date, which is very important, and using the word rent, because check was paid to the landlord by Mr. Smith using check, the bank. So rent, 5,000 naira. With that explanation, we'll bring this lecture to a close today. See you next time.
Do we start? Okay. Yeah, we are going to start with basically physics. Wave is defined as a disturbance which causes the transfer of energy from one point to another. As the energy is being transferred from one point to another, there is a particle shift without the displacement of the source of disturbance itself. Now, waves are classified into two. We have one, mechanical waves for their propagation. Let's say, for instance, when you have a swimming pool or a pool of water, you throw a stone inside the pool. When you throw a stone inside the pool, you see a ripple coming up from the source of disturbance. That is what we call wave. And then that wave is being produced as a result of the disturbance of the water or the pool of water by the stone itself. So mechanical waves are those waves that requires material medium for propagation. Example, mechanical waves are those waves that requires material medium for propagation. Mechanical waves are sound waves, wave on a ripple tank, waves on a string. These are examples of mechanical waves and more others. Now, these waves are being produced as a result of disturbance. For instance, when you clap your hands, two things are happening. One, there is compression and rarefaction, and this also produces a wave. On the other hand, we have electromagnetic wave. These are waves that does not require material medium for propagation. Example of these waves, examples of this wave are, we have light wave, we have S-rays. These waves does not require material medium for propagation. they are being produced on their own. And let's go back to mechanical waves. Mechanical waves are divided into two. Mechanical waves are divided into two. We have one transverse wave, and two, we have longitudinal wave. Now, what do you mean by transverse wave? Now, a wave is said to be transverse if the direction of the wave is perpendicular to the oscillation of the disturbance. That means, in that case, if you have a wave will be moving in this direction, while the source of disturbance, which is here, will be oscillating to and fro, to and fro, to and fro. This is a typical example of transverse wave. An example of transverse wave is wave on a repo water. Example, wave on a repo water, and waves on longitudinal waves. Longitudinal waves. Longitudinal waves are those waves that are being produced or where the wave is parallel to the source of disturbance, which means a wave might be moving this way. A wave might be moving this way, and then the source longitudinal waves. Now, let's go to what we call the mathematical expression of waves. Mathematical expression of waves. Now, if we have a wave, a plane progressive wave that moves from a source of disturbance. This is a wave that moves from a source of disturbance. Here is the disturbance. This is the direction of the wave. This is the oscillation of the wave. Now, as the wave is being oscillated, as the source of disturbance is being oscillated, the energy is being transferred from one point to another, producing this type of wave. Now, we have some wave parameters. One, wave parameters. One is what we call the wavelength. Now, when you come to a wave, while as the bottom is known as the trough. Now, the distance between two successive crests gives us what we call the wavelength, lambda. The distance between two successive crests gives us what we call the wavelength, or we say the distance between two successive troughs. Now, let's first talk about the period. Period T of a wave. Now, the period of a wave, as we all know, is the time taken for a wave to complete one cycle. Now, from here to this point gives us half of a cycle of a wave, and from here to here gives us another half of a cycle of a wave. It gives us one full cycle, and one full cycle gives us a period. Now, this is a period of a wave from the source of disturbance to this point gives us the period of a wave T. Now, this place represents half of a period, which is T over 2, while as here represents quarter of a period, T over 4. Now, as I said earlier, the distance between two successive crests gives us the wavelength of a wave, while as the time taken to complete one cycle, the time taken to complete one oscillation or one cycle of a wave gives us what we call the period of a wave. Now, let us talk about another parameter, which is the frequency of something else. The wavelength of a wave is measured in meters. The period of a wave is measured in seconds. Now, the frequency of a wave is the number of cycles produced per second. Let's take, for instance, you have an alternator or a generator in your house. As the rotor of the generator is rotating, the number of cycles or the number of revolutions made by the alternator or made by the rotor of the alternator gives you what we call the frequency. Now, the frequency is the number of this cycle. How many of these full cycles produced in a second gives you the frequency of the wave, and it is measured in hertz after a German physicist called James Hertz. So it's measured in hertz. So the frequency of a wave is measured in hertz. Now let us talk about the speed of a wave. Speed of a wave. Now the speed of a wave V, the speed of a wave is the product of the frequency of the cycle multiplied by the wavelength itself. Or you say the frequency, the velocity or the speed of a wave is the product of frequency and the wavelength of that particular wave. And the speed of a wave is usually moved in amplitude, which is also measured in meters, while the speed of a wave is measured in meters per second. Now, the amplitude of the wave represents the maximum point of a wave. This is the amplitude. This is positive amplitude. This place represents negative amplitude of a wave. This represents the amplitude of a wave, negative amplitude. This represents the positive amplitude of a wave. So it is the maximum distance of a wave, and it is also measured in meters. Now, let us go and talk about the mathematical expression of a wave. Now, we can talk about the mathematical expression of the wave by representing a sine wave. Now, let us talk about it. I will show you. The wave we have drawn so far is a sine wave. Now, if a wave starts moving from a source of disturbance, which means there is no phase, there is no phase shift, which means our y will be equal to a sine omega t. Omega is equal to theta over what? T. Now, omega is known as the angular velocity of the wave, which is the angle turned through by the wave over the time taken. Now, we can now make this the subject. You can say that theta is omega t. So we now substitute it, and then we now got this. A phase shift in a wave, which means we will introduce a parameter onto this function. Now, in that case, we will have something that looks like this. In that case, we will have something that looks like y is equal to a sine 2 pi over lambda into x minus vt. Now, this has introduced a shift inside a wave. The presence of this introduced a shift inside a wave, and I will explain the meaning of this. Now, if we have a wave, let's say these are two waves. This is one of the waves. And then, if a wave comes after the origin, That means if we have something like this, there is a shift here. This phase shift here means this is phase shift. This phase shift is this. A peak and then come. Then we have another wave that now, we have another wave that let's say that moves from here to here. Now there is a shift here. So that phi here, which is the phase shift of the wave, is positive. So we will now have that y is equal to a sine 2 pi over lambda into x minus plus vt. So this is wave equation. Now, a is the amplitude of the wave number, while as this one represents the angular velocity of a wave. So let us move. Now, a typical example could be given to us in exam. Maybe in exam, a question might be said, if y is equal to, let's say, 2 sine into 4x find the frequency of shift. You know that one wave moves from the origin and then there is another wave that comes after the origin, so which means we have a phase shift here. Now from our wave equation, we will know that y is equal to 2 sine 4x minus 5t. And then we were told to calculate the frequency of the wave. So from wave equation, y is equal to a sine into 2 pi x over lambda minus 2 pi over lambda vt. Now we will now do what we call comparing coefficient. We will now do what we call comparing coefficient. We will now compare this to this, so that we can be able to compare our equation to this, so that we can be able to calculate the frequency of the wave. Now, let's say we have from the above equation, if and the wavelength equal to 2 meters. We can now calculate it. We can now say y is equal to a sine into 2 pi x over lambda minus omega t, because the whole of this represents omega. Because if we start analyzing this, we know that frequency is equal to velocity over lambda. So we can now represent this as frequency, where we now have omega, which is the whole of this, because omega is equal to 2 pi v over t. Because we are going to substitute the whole of over lambda, because we substitute the whole of this as f. So we now have omega is equal to 2 pi f. That's why we have 2 pi t. We can now start making our comparison from the equation. So from here, we have omega is equal to 5, but omega is equal to 2 pi f. So therefore, 2 pi over 2 times 22 over 7, which is 5 over 44 over 7, which is 5 divided by 44 over 7, which is 5 times 7 over 44, which is 35 over 44, which will give us a value of 0.3 something. So now the unit is in hertz. So I've been able to calculate the frequency of the system. Now, another example could come like this. Another example could come like this. This was taken from a typical JAMB question. It says that the distance between two successive crests of a wave is 15 cm and the velocity is 300 meters per second. Now we should calculate the frequency. Now, we have a wave. The distance between two successive crests is given as 15 cm. And then the velocity of the wave, the speed of the wave along the x direction, v, is equal to 300 meters per second. Then that we should find the frequency of the wave over lambda. But first of all, you need to, because we have our unit to be in cm here, in meters here, the unit here is in cm. So you need to convert the wavelength to cm. So wavelength lambda is equal to 15 cm, which is 15 divided by 100, which is 0.15. And now calculate our frequency. Our frequency will be equal to 300 meters per second divided by 0.5 times 10 to the power minus 1 meters. Now it will be 300 over 1.5 times 10 to the power minus 1 over second. This will give the power what? 3 times 10 to the power 3 all over 1.5, which is the same thing as 30,000 divided by 15. So 5 can go here, we have 3. Or 3 can go here as 5. Then 3 can go here as 10,000. Now 5 can divide itself 1. 5 can divide 10,000 as 2. So the frequency is 2,000 Hz. Now let us talk about the characteristics of a wave. Wave, as we all know, has numerous characteristics. A wave refracts. Characteristics of a wave. 1. We talk of refraction. Refraction of waves. 2. We talk of reflection. Reflection. 3. We talk of diffraction. 4. We talk of interference. 5. We talk of polarization. Now, let us start with refraction. Refraction has to do with the bending away of light, or bending away of, when I say light, is wave, between two media. Let's say we have, this is a boundary between two media. Here is air, and then this is oil, or oil, could be oil or water or anything, or glass. A particular incident angle, I. The light, the refracted angle will bend to say 38 or let's say 30 degrees. Because one, the frequency of light or the frequency of the wave will be the same. That is the frequency of the incoming light and then the frequency of the wave inside the oil or the material or glass or water will be the same, but the velocity will be different. Why is it that the velocities are different? The velocities are different because of the densities of the two media. Because the speed of sound or the speed of light in air is faster than the speed of light in oil or water, because of the densities are different. This medium will be more denser. This is a denser medium, while as this one is a less dense medium. Next with the normal, that is the incident angle, is the incident angle is the angle which the incident ray makes with the normal, while this is incident ray. It's just like when I say light, it could be light from the sun, it could be light from a candle, it could be light from the ceiling fan, it could be light from gamma rays or light from alpha particle or anything. So the incident ray is being produced by all these sources I have mentioned. Refraction is this, that in refraction, the incident angle is always bigger than the refracted angle. Why? Because the velocities of light in the two media are different. When light is moving from air to glass, the velocity of light in air or the speed of light in air is faster than the speed of light in this medium. Now, as you are increasing the incident angle, the refracted angle will be what? Decreasing, until a point when the refracted angle will now come to this particular point. Now, conversely, or on the other hand, we can also make a situation, we can also have a situation whereby light moves from, let's say, oil, groundnut oil to air, which means we'll have, here is oil, and then this is air. Now, we have our incident angle here, inside the oil, and then we'll be having our refracted angle here, also inside the oil. Now, what happens in this case is that as the incident angle is increasing, the refracted angle is also increasing. Now, as we all know, this media or this medium is very, very dense. So the speed of light in this very medium will be less. It will not be faster than that of air. Now, as you are increasing the incident angle, the refracted angle will be also increasing. But there will be a time when the incident angle will produce a refracted angle that will be at this particular point, will be at the boundary, because this is the boundary between the two media, between air and oil. And that particular incident angle which produces the refracted angle to be at 90 degrees, it's what we call the critical angle. Now, from Snell's law, which says that the ratio of sine angle of the incidence, that is the incidence angle, over sine angle of the refraction is equal to refractive index. Refractive index. Say that sine incident over sine critical is equal to n sine incident over n. Now, that particular angle of incidence that gave us the refracted angle to be what? We will now have a refracted ray that will be light. A light refracted ray. Now, it has now refracted into the air, not in the oil again. Now, that phenomenon in which we have that process. Instead of the light to refract inside the oil and inside the oil, but now it goes into the air, is what we call total internal reflection. So total internal reflection is the process. At critical angle, the refracted angle is 90. So further shift or further increase in the incident angle, which is at this point. If the incident angle is at this point, I now. So we will now have a refracted angle, which is here. That particular point is what we call total internal reflection. And for total internal reflection to occur, two conditions has to take place. One, light has to move from denser to a less dense medium. That is one, which means light has to move from oil to angle has to exceed the critical here, and then we'll do justice to it. We are going to pick up a question and do one. Now, what? We might have a diagram that looks like this. This is a normal. Now we have incident angle coming in. We have a refracted angle, which is R. And then this is incident angle, let's say 30 degrees, the incident angle. Now here, refracted angle in a glass degrees. Now all we need to do is that we need to now start working by saying solution from Snell's law. We have that sine I over sine R is equal to M. From our question, we have been given that I is equal to 30 degrees. And we all know that refractive index N of glass, refractive index of glass is equal to 1.5, and 1.5 is the same thing as 3 over 2. So we can now say that 3 over 2 is equal to sine 30 all over sine R. Now we can cross multiply. We will now say but is equal to half over sine R. So we have that 3 over 2 sine R is equal to half. Then sine R will be half divided by 3 over 2, which is half times 2 over 3. This will cancel this. We have sine R will be 1 over 3, which is 0.333. Now R will be equal to sine inverse of 0.333, which will give us something like 46.2 degrees. Now this is the refracted angle. This is the refracted angle. So we have been able to do that calculation. Now let us now talk about the reflection of light as one of the characteristics too. As we all know, typical example of a plane mirror. In the case of a plane mirror, if this is a plane mirror which is being silvered, and this is the normal. Now, if this is the normal to the plane mirror, and this is the incident angle or incident ray, coming in. This is the incident angle I. Now, the refracted angle reflects on a plane surface. When light reflects on the plane surface, only on plane surface, the incident angle is equal to the refracted angle. But if light reflects on a rough surface, something like this, so the incident angle that is coming like this will not be equal to, some of them will go like this, some of them will go like this, some of them will go this way. While as for a plane surface, if the incident angle or the incident ray comes, these are reflected rays. But for a rough surface, the incident light, for a rough surface, the incident light will not give us the same thing as the reflected light. Some will go back because the surface is not okay. So which means reflection still obeys the law of the Snell's law, which says that the ratio of sine angle of incident to the sine angle of refraction or reflection is equal to a constant. That means sine incidence over sine reflection is equal to a constant. Why the constant depends on the nature of the material. You find out that this is a very smooth surface. This is another very smooth surface. So the refractive index of this board will be different from the refractive index of the seat because they are quite distinct. They are different surfaces. Now, let us talk about the third one. We talk of diffraction. Now, diffraction, as we all know, diffraction has to do with the bending away of light from a small opening. Now, let us say we have something like a slit. And then a wave is coming. If this is a wave coming, when the wave gets down here, gets down to this slit, they will form a curve that looks like this because of this surface. Now, a practical application of this diffraction has to do with our door. It is because of diffraction that when you close your door, that somebody who stays outside will be hearing what you are discussing with your friend or your family. Now, interference has to do with the combination or the addition of two waves to form a singular wave, or the subtraction of two waves to form a singular wave. Now, interference has to do with addition or subtraction of two. We have a wave in which y is equal to a sine omega t, and another wave, this is wave A, and y, wave B is equal to a sine omega t. Now, if the phase of these two waves are the same, that means if these two waves move in phase, move down again, reach the positive peak at the same time and move at the same time, these two waves are said to be in phase. Now, if the two waves are in phase, we will have that ya plus yb will give us a sine omega t plus a sine omega t, which is 2a sine omega t. This tells us that the amplitude of the wave has increased because the two waves are in phase. So the wave we are going to generate, or the resultant wave, will be the bigger and the big phase. Now, why are we saying this? I am saying this because the two waves are in phase because they live at the same point, reach their peak maximum at the same time, and come to zero at the same time, reach their negative at the same time, and also come to zero. Mathematically, this is it, because we are adding wave A plus wave B. It's now generated something like this. Now, when two waves are said to be destructive, in this case, we say that these waves are constructive interference. Now, for destructive interference, which means that the two waves are out of phase. When we have two waves being out of phase, we say that the two waves are said to be destructive. Now, let's say we have one wave. One of the waves, one has a positive shift. This one has a negative shift. So we have that if we have it, we say YA is equal to, if we are taking this as wave A and take this one as wave B, we now have that YA is equal, and then YB will be equal to A sine 2 pi over lambda into x minus Vt. Now, when you find out, when you add these two waves together, you find out that we are going to get a smaller wave. So we have wave A minus wave B will be A sine 2 pi over lambda into x plus Vt minus A sine 2 pi over lambda into x. Size are very small. So in that case, we'll produce what we call destructive. That's another property of wave, where we talk about polarization of wave. Polarization. By polarization, we are talking about the nature of the wave that we are producing when a wave passes on a thread. This is another slit. It's another slit. Now, a wave is being opened at the same particular position. Let's say at the same particular position, which means the wave has to pass through it. And then since now, but a situation whereby one of the slits is being readjusted. Let's say we readjust the slit at the middle. Now, instead of opening it at the center, we now open it here. This one is at the center, this one is at the center. So once we have a wave that comes in and pass through the first one, the wave will come here and quench. That is what we call polarization of a wave. So with this, we have come to the end of waves in pipe. Longitudinal waves in pipe. Longitudinal waves in pipes. Now, by longitudinal waves in pipe, what we mean here is that we are going into a pipe and then one end of the pipe is being closed. We say that that pipe is a closed pipe. A typical example is the end of the pipe and then reflects back. Now, this end of the pipe where the air particles are fixed is what we call the node. While the end of the pipe where the air particles are freely to move are what we call the antinode. Now, the length of this the distance from here to here gives us that L is equal to lambda over 4, and this is FO. Why is it lambda over 4? It is lambda over 4 because when we draw a wave form, lambda represents distance between successive crests or successive trough. Now this represents, for that we say that L, that is the length of the pipe, is equal to lambda over 4. For the first is equal to FO will be V over lambda, which is V over 4L. So FO is equal to V over 4L. This gives us the fundamental frequency of a closed pipe. Now, for the first, we'll have this represents quarter of a wave because we have lambda over 4. This represents half of a wave. We have lambda over 2. So we have LCM 4. We have lambda plus 2 lambda, which is 3 lambda over 4. Therefore, the length of this pipe represents L equal to 3 lambda over 4. So therefore, 4L is equal to 3 lambda. So lambda is equal to 4L over what? 3. Now the frequency of the first over, which is V divided by 4L over 3. So F1 will be V times by 3 over 4L, which is 3V. That is the first, this represents the first overtone. Now for the second overtone, of a closed pipe, we have that we have here as lambda over 4, lambda over 2, lambda over 2. That implies that the length of the pipe will be L equal to lambda over 4 plus lambda over 2 plus lambda over 2. Diagrammatically, we can represent this as this. Using our wave equation, this place represents lambda over 4. This place represents lambda, which is the same thing as lambda plus 2 lambda plus 2 lambda plus V divided by 5 lambda over 4, which is V divided by 5 lambda over 4, which is V times 4 over 5 lambda, which is equal to 4 V. Now that L is equal to 5 lambda over 4. So 4L is equal to 5 lambda. So lambda is equal to 4L over 5, which is V divided by 4L divided by 5. So F2 will be equal to V times 4L. So F2 will be equal to 5F2. So therefore, all we need to know here is that for closed pipe, the individual notes or the individual overtones are only odd harmonics. That means for closed pipe, the individual overtones are all odd harmonics. That means we have that F5. By open pipe, we mean that both ends of the pipe are open. For open pipe, L is equal to, this is lambda over 4 plus lambda over 4, which is L equal to 2 lambda over 4, which is lambda over 2. So FO will be equal to V over 2L. That is for first overtone of an open pipe. Now, for this is fundamental frequency of open pipe. Then for first overtone of open pipe, we'll have in that case we have L. Here is lambda over 4, lambda over 2, lambda over 2. So we have that this is FO. L will be lambda over 4 plus lambda over 2 plus lambda over 4. So we have lambda plus 2 lambda plus lambda, which is 4 lambda over 4, which is lambda. So L is equal to lambda. So it is important to know that it is only in first overtone of an open pipe where the length of the pipe is equal to the wavelength. Very, very important, because it's a jam question. So in that case, we have that F1 will be equal to V over lambda, which is V over L. That is it. Now let us talk about the second overtone of open pipe. Lambda over 4, lambda over 2, lambda over 2, over 4 plus lambda over 2 plus lambda over 2. So L will be 4. Here will be lambda plus 2 lambda plus 2 lambda, which is what? 5 lambda over 4. Isn't it? Five lambda over 4. So in that case, we have that 4L is equal to 5 lambda, and lambda is equal to 4L over 5. So F2 is equal to V over lambda, which is V over 4L over 5, which is V divided by L over 5, which is 5V over 4L. No, sorry. So let's go back again and revisit our question. Now for F, for F2, where we have L, here is lambda over 4, lambda over 2, lambda over 2. So we'll have this as 4 plus 2 lambda plus 2 lambda. Oh. So we will now have 5 lambda over 4. For second overtone, it's going to be like this. Which is, you represent it as a wave, is a full wave. So if here is lambda over 2, and here is lambda over 2, lambda over 2, that means L will be equal to lambda over 2 plus lambda over 2, which is 2 lambda over 2. So which is equal to L. So in that case, we have that F1 will be equal to V over lambda, which is equal to V over L also, because lambda, which is the wavelength, is equal to the length of the pipe. So it is only in the first overtone whereby the length of the pipe is equal. That is where the lambda is equal to. That is where the lambda is equal to the length of the pipe. We'll have that this quarter we have here as 4. That means we have here as lambda plus 2 lambda. So 3 lambda is equal to 4L. So lambda is equal to 4L over 3. So F2 is equal to V over 4L. So one thing we have to understand is that for F2, we have 3V over 4L. That implies that in open pipe takes both, the overtones are both odd and even harmonics, while as in closed pipe, it takes only odd harmonics. That is the major difference between open pipe and closed pipe. One, that the closed pipe takes only odd harmonics, while as open pipes take both odd and even harmonics. Another difference is that it is only in first overtone of the open pipe that the length of the pipe is equal to the wavelength. Now we are moving to another topic. Let's talk about energy quantization. Energy quantization. By energy quantization, we mean that the energy given out by every matter when heat or when light or sufficient energy falls on them are given in discrete form. That is, energy E are equal to 1, 2, 3, 4, 5, 6, and so on and so on are emitted. Now, the emitted electron or the amount of electrons that are being emitted depends on the amount of light that falls on it. And it also depends on the frequency of the incident light. Now, let's take, for instance, that we have a metal. This is a metal of sodium. And then we have an incident ray of light from, let's say, alpha particle. Now, when this light falls on it, when this light or when this energy falls on this, the electrons inside here will start gathering energy. They will start gathering energy until a particular point they will now peak off and then be liberated. Now, the energy of the incident light that is coming in to liberate electrons inside this metal are given as E equal to NHF. Now, N represents what we call the principal quantity. So if we have, let's say, sodium, as we have known, sodium has atomic number of 11 and mass number of 23, for instance. That means that we have 2 electrons here. We are going to have N here represents the energy level. This is energy level 1, energy level 2, energy level 3. Start moving either down or up, depending on the direction in which they are moving. Now, if we have a metal in which energy leaves from, or in which electrons leaves E3 minus E1 and is equal to NHF. Now, this represents energy level in the upper state, which is in orbit 3. This represents the energy level in lower state, which is orbit 1. Then this represents the principal quantum number. That is the energy level where of the incident light. That is the light coming either from the sun or from the alpha particle or from the star or anything. So in that case, we can be told to calculate the frequency of the incoming light. So frequency of the incoming light will be E3, which is energy level at the upper 3 minus U. The energy which an object is giving out when sufficient light of a frequency falls on it is given as E is equal to HF. Now for this to happen, for those electrons inside the atoms to start moving or being liberated from the metal, these metals has to get a certain amount of energy from the incident light. So that energy E is equal to WO plus. Work function depends on the kind of metal as well. Now, metals that are higher in the periodic table will have more work function than metals that are lower in the periodic table. For instance, sodium will have more work function than magnesium because sodium is